right. So this is question 4 from the week 6 exam review, and it says activity trackers are electronic devices that people wear to record physical activity. Researchers wanted to estimate the mean number of steps taken on a typical workday for people working in New York City who wear such trackers. A random sample of 61 people working in New York City who wear an activity tracker was selected. The number of steps taken on a physical workday for each person in the sample was recorded. The mean was 9,797 steps, and the standard deviation was 2,313 steps. It says construct and interpret a 99% confidence interval for the mean number of steps taken for a typical workday for all people working in New York City who wear an activity tracker. So, first and foremost, we want to identify the type of confidence interval that we are going to create. So this is going to be a one sample confidence interval for mu. And in this case, mu represents the true mean number of steps on a typical workday. Let's say for working New Yorkers. All right. And so that's the first important thing you can do. Remember all of our statistical inference, right? So creating confidence intervals and running significance tests. You're either going to be doing these for a mean or for a proportion. So the first step is identify which. In this case, we're doing it for a mean. All right, so step 2, we need to check our conditions. So my first condition, I'm going to say that this was a random sample of New Yorkers. Condition 2, so this is the 10% rule, and you're just going to multiply your sample size by 10, and we're going to say, so 61 times 10 is 610, so we're going to say the population of New York is definitely greater than 610. And then condition 3 is large counts, and so for a mean, large counts just needs to be greater than 30. So large counts is satisfied. All right, and so once we've done that, we can move on to creating the confidence interval. We've already named it. So you can do this by hand using the formula, which would be you use your sample mean, and then we're going to add and subtract a margin of error. So that margin of error is going to be our critical value. I'll call that Z star. Or actually, in this case, since it's for a mean, it would be T star. And we would multiply that by the standard error, which for us is going to be sample standard deviation over root n, right? This seems pointless to me. You can totally use your calculator. The AP exam accepts this. So that's what I'm going to do. So let's pull up our calculator, and we just need to remember the mean was 9,797. Standard deviation is 2313. And so we're going to go to stat tests. And what we want is, remember, if it has prop, it's for a proportion. And if it doesn't have prop, it's for a mean. We want a t interval in this case. The only time you would ever use z interval is if for some reason you need you knew the population standard deviation, but generally you will not know that. They only gave us the sample standard deviation in this case. So T interval. So input, either raw data or stats. Since they gave us the stats, we'll use this. And our sample mean was what? Oh boy, I already forgot. 9797. So 9797. And our sample standard deviation was 2313. And our sample size was 61. And the confidence level that we want is 99, so 0.99. And then we'll just go ahead and calculate that. Let me write this down real quick. So let's see, we have an interval of 9009.2 to 10,585. All right, so let's go back to our page. And we'll just go ahead and conclude, right? So our conclusion is that what we are 99% confident that the true mean number of steps for working New Yorkers falls between 9,009.2 and 10,585 steps. Great. And so let's move on to part B. A wellness director at a company in New York wants to investigate whether it's unusual for one person working in the city who wears an activity tracker to report approximately 8,500 steps on a typical workday. Is it appropriate to use the confidence interval found in part A to conduct the investigation, and explain your answer? So in this case, it might be tempting to say, well, 8,500 is well below this list of plausible value, or this interval of plausible values. But remember, this interval is for plausible values of the mean and does not take into account what the range of possible values could be. This is just an interval estimating the mean number of values. So the answer there would be no. This interval gives plausible values for the mean and then I will say not the range. All right, hope that helps, folks.